Just a moment. Start, man.
Hello, good morning, students. Welcome back to the chemistry classes. Yeah, we have already started the chapter that is stoichiometry. This is the part 2. Have you all gone through the textbook? In the last class, we have dealt about what is stoichiometry. Stoichiometry, it deals about measurements. Okay? Why are we learning all this is because in order to carry out the reactions, we have to get the maximum product, right? Maximum yield of the product. So for that reason, what are the conditions, how to carry out a reaction, all this we will be learning in this chapter. Also, we have discussed about the states of matter, interconversion of state, that is conversion of a solid to liquid, liquid to gas. What are the conditions required we have dealt. Okay. So today we will be seeing about measurement. So what is measurement? See, in our daily life, we measure everything, right? We will be carrying out measures in order to not waste the things. Okay? So in chemistry, what things are we measuring? Let us see. And whenever we are measuring, accuracy will not be there. For example, if I ask a girl to measure 100 ml of water, okay, does she exactly measure the same amount? No. If I ask to the other girl, there might be little differences. Okay, 1 or 2 ml will be varying. A girl may measure 99 ml and she treats it as 100 ml. Another girl may measure 101 ml and she treats it as 100 ml. That means there is no accuracy. Okay, we will not be getting the exact values. So that is what is called as uncertainty. So what is all that we will see here. Yeah, uncertainty in measurement. See, every experimental measurement has some amount of uncertainty associated with it. Just now I gave you an example, right? So if we are asked to measure 100 ml, we will not be able to measure it accurately because there are certain human differences from one person to the other, right? So we will not be able to exactly measure. So that is what is uncertainty. One would always like the results to be precise and accurate. Yeah, in order to get the correct results, what we have to do? Our measurements should be accurate and precise. So what is precision? Let us see here. Precision refers to the closeness of various measurements for the same quantity. Okay? So what is precision? It is the closeness of various measurements for the same quantity. This is important. Okay? So whenever we are measuring the things, we will not be getting the exact value, right? Our values would be somewhat closer to it. So that is what is called as precision. Now let us see what is accuracy. Accuracy, it is the agreement of a particular value to the true value of the result. So what is accuracy? It is the agreement of a particular value, okay, to the true value of the result. So why are we discussing all this? Means in the second year, you will be carrying out titration reactions. So what is titration reaction? Titration is nothing but the reaction between, generally you will be carrying out the titrations of acids and bases. Okay, we will be adding the acid to the base with the help of the burette. Okay, so what happens is, while carrying out the experiment, few students, there is not only few students, every human being, while adding, what happens is to the exact value, we will not be stopping it, right? We will not be closing the nozzle of the burette. So some extra amount might be falling down. So that means, so for whenever we are doing titrations, we will be carrying out the experiment at least thrice in order to get the accurate results. So what are accurate results, or what is accuracy? It is the agreement of a particular value to the true value. That is what is called as accuracy. Okay, next let us see. The uncertainty in the experimental or the calculated values is indicated by mentioning the number of significant figures. Okay, just now I don't know. Actually, while you will be calculating, you are doing the titrations. Suppose you have to get the value of about 20 ml. Okay, so let us say two students are there. One student is getting it as 19.5 ml and the other student is getting it as 20.5 ml. So which value is closer? Actually, you have to get it as 20 ml. So your values are somewhat closer to 20, but not exactly 20. So for that reason, in order to get the accurate results, we will be repeating it. And we will be seeing the certainty in the measurement. Okay. Significant figures are meaningful digits which are known with certainty. Example, 11.2 ml. 11 is certain and 2 is uncertain. Okay. So we'll go with the further examples, then you will understand it better. Okay, you please keep this in your mind. For example, whenever we are carrying out an experiment, we will not be getting the exact measurements. Okay, our values will be somewhat closer. They will be plus or minus here and there. So that is what is uncertainty. Next, let us see the rules for determining the number of significant figures. So already you have learned this in your lower classes about decimal points, how to round off the figures. Okay, a little bit math we will be discussing over here. Okay, let us see. Any digit that is not 0 is significant. Okay, so let us see here what it is. Any digit that is not 0 is significant. You see here in this example, it is 4.2183. So total how many digits are there? 1, 2, 3, 4, 5. So because 5 digits are there, we are saying that it is 5 significant figures. Okay. Next rule we will see. Zeros between non-zero digits are significant. So what does it mean? Let us see here. See the example, what it is, 80.0054 lb. So in this, let us see, count the number of digits. The digit is starting from 8 to and ending to 4, right? So the digits are non-zero. The starting digit is non-zero. That means it is not 0, it is 8. So let us count the digits here. 1, 2, 3, 4, 5, 6. So that means this number has 6 significant figures. And you see here what you have to notice is the zeros are between non-zeros. So what are the non-zeros here? 8 and 5. In between these, we are having 3 zeros. So these zeros also have to be counted as significant figures. Okay. Next, let us see. Zeros to the left of the first non-zero digit are significant. So what is here? Let us see here. What is the number given here? 0.00 00349. Okay, so here see here, the number is starting with 0. Okay, and there is a decimal point, and after the decimal point also we are having 4 zeros. So zeros to the left of the first non-zero, that means here these zeros after the decimal point, how many zeros are there? 1 2 3 4. Okay, these zeros should not be counted as significant, they are insignificant. Okay, so how many number figures are there? How many non-zero digits are there? 3. That is 349. So this 349 is the number of significant figures for this particular value. Okay, hope you have understood. Next rule, let us see here. For numbers containing decimal point, okay, all the trailing zeros. So what is this trailing zeros means? The zeros obtained at the end, last, okay, after the decimal point, whenever we are doing out the calculations, we'll be getting zeros, right? That zeros are called as trailing zeros. All the trailing zeros count as significant figures. Let us see an example over here. See this number, 3.400 centimeters. Okay, so what are the trailing zeros here? Here after 4, right? 3.400. That means we have to count these zeros also. These zeros are significant. Okay, significant in the sense what? They have certain value. Okay, so total number of figures in this is, count the digits. See here, 1, 2, 3, 4. So here we are having 4 digits. 3.400. So this has 4 significant figures. Next example, see here. 0.0200500. Okay, so after the decimal when 0 is there, that we should not count it. Okay, because it is to the left of the significant number. What is the significant number here? It starts from 2. So 2 is the significant. So because 0 is present before or left to 2, we are not counting it as the significant figure. So we have to count the significant figures from here. So see here, how many figures are there? Let us see. 2, 0, 0, 5, 0, 0. So total number of digits are 6. So this case has 6 significant figures. Okay, hope you have understood. So these are the trailing zeros, 500, right? These zeros are occurring at the end, so we call it as the trailing zeros. So for numbers containing decimal point, all the trailing zeros are considered as significant figures. This we have seen. Yeah, next. Let us see. For numbers do not contain decimal point, the trailing zeros may or may not be significant. Okay, so let us see the example. Here the number is 6800 and it doesn't contain any decimal point. So whenever there is no decimal point, the trailing zeros may or may not be significant. Okay, so we can say that this number has 4 significant figures, or it is 3 or 2. Okay, so in order to avoid ambiguity, what is ambiguity? Confusion. So in order to avoid the confusion, we have to use the scientific notation. Okay, hope you have understood. Let us quickly see. Any digit that is not 0 is significant. That you have to see. Zeros between non-zero digits are significant. Zeros between non-zero digits are significant. Next, zeros to the left of the first non-zero are not significant. When this point you need to keep in your mind. And all the trailing zeros are significant. Trailing zeros means zeros at the end of the number after the decimal point. Okay? So this is about significant figures. In mathematics, you might have already learnt how to round off the figures, right? In your smaller classes, as well as now also, whenever you are doing the numericals, but that is the problems, you have to round off the figure. For example, if you get 1.99, what do you do it at? You will take it as 2. Okay? So now let us see rules for calculating with significant figures. Okay, rules for calculating with significant figures. So already we have discussed what are the fundamental operations: addition, subtraction, multiplication, and division, right? So these are the fundamental operations. So we will be going through few examples. Okay, whenever we are dealing with the significant figures. What are those? Let us see here. Rules for calculating with significant digits. When adding or subtracting, round the answer to the least number of decimal places. Okay? So let us take this example. See the example, 1.457 plus 83.2, sorry. Okay? 1.457 plus 83.2. So whenever we are adding, so what is the answer you are going to get? 84.657. So the answer is having how many digits, how many significant figures? See the answer, it has 1, 2, 3, 4, 5. 5 figures we are getting. Okay. So what we are doing, the final answer, we are writing it as rounding it off to 3 figures. Okay. Why 3 figures? Because in the problem, we are having the least number of figures is 83.2. It has only 3. So our final answer should also contain 3 significant figures. For that reason, we are rounding off 84.657 to 84.7. Okay? Hope you have understood. You please practice this. You take any 2 or 3 digit numbers. You frame the number. You take few digits, write down and round off. You can create few problems of your own. And just follow the rules and round it off. Next, see another example of subtraction. So in this case, we are seeing 0.0367. From that, we are taking out what? 0.004322. So among these two numbers, you see, which one has least number of significant figures? The first number has 3 significant figures and the second number has 4 significant figures. Okay? So the final answer of ours should contain 3 significant figures. Okay? So after subtracting this, what are we getting? 0.032378. Okay? So how many digits are we getting? 1, 2, 3, 4, 5. 5 digits we are getting. right? So among these two numbers, it has only 3 significant figures. So we have to round off to 3 significant figures. Okay. So same thing applies over here also for the multiplication and division. So see here, 4.36 is multiplied with 0.00013. Okay, this number 4.36, it has 3 significant figures, and this number, it has only 2 significant numbers. So once we get the final answer, we have to round it off to 2 significant numbers. Okay, so what is the answer we are getting? We are getting it as 0.0005668. So this contains 4 significant numbers. So what we have to do? We have to make it to 2 significant numbers. Okay, so we are rounding it off to 0.00057. Okay, actually it is 56. Okay, see that we have to make it to the 2 figures, right? So in order to make the number into 2 figures, what we are doing? We are considering the third digit. What is the third digit here? 6. Okay, this 6 is greater than 5. If it is greater than 5, what we have to do? We have to add 1 to the previous one. So we are writing it as 57. Okay. Next, let us see another example where we are dealing with division. Okay, see here, 12.300. This is divided by 0.0230. Okay, so among these two numbers, which one has the least number of digits here? This has 1, 2, 3, 4, 5. In the numerator, we are having 5 significant figures, and in the denominator, we have 3 significant figures. So after division, our answer should contain 3 significant figures, because among these two numbers, the one which has least number of significant figures is 3. So we have to round off our answer to the 3 significant figures. Okay, so we are making this 534.78261 to 535. So this is a rounded off value. Okay, actually, you know, all these, you have already done this in your lower classes, but now you are understanding it with the rules. Okay, so don't panic. This is easy only. What are you are doing right from the lower classes, that only we are learning as the rules. Next, let us see dimensional analysis. Okay, another subtopic is dimensional analysis. So what is this? Let us see. Analysis using the fact that physical quantities added or equated with each other must be expressed in terms of the same fundamental quantities, such as mass, length, or time. So what are these? Length, mass, and time. These are the fundamental quantities that you have learned over here. Okay, this is the important point. These are the fundamental quantities for references to be made about the relations between them. Next, let us see here. What does that sentence means? We'll see over here. Translation: making sure you have all the right units. That means whenever you are converting or adding, for example, I'll tell you, add 10 kilometers to 35 meters. Can you directly add? No. You have to convert the kilometers into meters, then add meters. Okay, that means whenever we are carrying out the Either these, all these four operations, that is addition, multiplication, subtraction, anything, whatever we are doing, we have to see that all the quantities are in the similar units, same units. Okay, just now an example I told you. Suppose if I am telling add 70 kilometers to 100 meters. So what do? You have to either convert this 70 kilometers into the meter or convert this 100 meter into the kilometer. Then only you can add. Simply you cannot add 70 plus 100, that is 170. That is wrong. Because these two are differing in their units. Okay? That is what the above sentence you have read. Okay? So let us see an example over here. Convert 24 kilometers per minute to meters per second. Okay, so what we are doing here, we are converting 24 kilometers per minute into meters per second. So we know that 1 kilometer is equal to 100 meters. Okay, and 1 minute is equal to 60 seconds. So see here, they are just substituting it. Okay, kilometer, 24 kilometer has to be written as 24 into 1000 meters. And minute has to be multiplied into 60 because 1 minute is 60 seconds. So we get it as 400 meters per second. Yeah, next. Another important subtopic, that is atomic weight and atomic mass. Okay, this is very, very important, children. You please make a note down of it as well as practice it. Okay, this is very, very, very important topic, because based on the atomic weights only you will be getting the correct molecular weights, and based on the molecular weights we will be getting the correct number of moles. And if you get correct number of moles, then only you will be able to get the correct answers in doing the problems. Okay, so in order to get final result as to be correct, you have to learn this thoroughly. Okay, all this you have already learned in your 9th and 10th. Okay, so what it is, let us see here. Atomic weight and atomic mass. Okay, so what is atomic mass? Let us see here first thing. Atomic mass is the sum of protons and neutrons of a single atom. Okay, you know that every substance is made up of, any substance is made up of molecule. Yes or no? And the molecule is made up of atoms. And atom is made up of what? Electron, proton, and neutron. This you have learned. This you are learning right from 9th class. Atom is made up of electron, proton, and neutron. Okay? And the nucleus is at the center of the atom, and the electrons are revolving around the nucleus. Okay? So the center of the atom is called as nucleus, and nucleus has neutrons and protons. Okay, these are present in the nucleus, and electrons are revolving around the nucleus. This is what is an atom. Okay, see this figure. Neutrons and protons, this is the nucleus, and electrons are revolving around the nucleus. Okay, this is what is an atom. And neutrons and protons, they are present in the nucleus, right? So these are also called as nucleons. So what are nucleons? Neutrons and protons are called as nucleons. Okay? And another thing what we need to know is the weight of the atom is because of the nucleus. Okay, electrons are very much lighter particles. Because of that only they are able to revolve, because they are revolving, and it is the lightest particle. Okay, so whatever the weight of the atom is there, it is because of the nucleus. And what is present in the nucleus? Protons and neutrons. So this number of the sum of protons and neutrons of a single atom, that is what is called as atomic mass. Okay, what is atomic mass? It is the sum of the protons and neutrons of a single atom. Okay, now let us see what is atomic weight. Atomic weight is the weighted average of the atomic mass of all natural isotopes of an element. Okay, so another term what we are seeing, isotopes. Already you have learned in your first and second chapters of chemistry. What are isotopes? Isotopes are the elements with the same atomic number but different mass number. Okay, mass number is different over here for the isotopes. Why is the mass number different? Because they are having different number of neutrons. Okay, isotopes of an element will differ in the number of neutrons. Okay, for example, if you take carbon, okay, in nature we are having 3 types of carbon, or we can say that 3 isotopes of carbon. Okay, what are the 3 isotopes of carbon? We know that atomic number of carbon is 6. Okay, so among the 3 isotopes, one isotope is having atomic mass as 12, another has atomic mass of 13, and another has mass of 14. So total how many isotopes of carbon are there? 3. Okay, so we can call it as simply as C12, C13, C14. Okay, now among these 3, 99% is about C12 only. Okay, so but while taking the atomic weight, we are considering the weights of even C13, C14. So all this, we are taking the average of C12, C13 and C14. Okay, because all these 3 are the isotopes. So that is what is the average weight of the isotopes of an element gives us the atomic weight. Okay, atomic weight is the weighted average of the atomic mass of natural isotopes of an element. Okay, hope you have understood this. Yeah, next to see here. Another important subtopic is molecular mass. So what is molecular mass? Let us see here. It is the sum of atomic masses of all the atoms present in the molecule. Okay, what is a molecule? Molecule is nothing but which is made up of 2 or more atoms. The atoms can be same, the atoms can be different. Okay, for example, let us take oxygen molecule. What is the formula? O2. Okay, that means oxygen molecule is made up of 2 atoms of oxygen. Okay, so what would be the molecular weight of oxygen? Molecular oxygen 2 into 16. Okay, because each oxygen, its atomic weight is 16. So we are getting the molecular weight by multiplying it with 2. Hope you have understood. We'll deal with the examples. Okay, another example, water. What is the formula of water? H2O. Okay, that means 2 atoms of hydrogen is combining with 1 atom of oxygen to give water molecule. Yes or no? Yes, that means 2 hydrogens. So in order to get the weight of water molecule, you have to consider the weights of hydrogen and oxygen. Okay, so upon adding the weights of 2 hydrogens and 1 oxygen atom, then you will get the molecular weight of water. Okay, so that is what we'll see here. It is molecular mass is obtained by multiplying the atomic mass of each element by the number of its atoms and then adding them together. Okay, let us see the examples. We'll understand it clearly. See the example here. Find the molecular weight of ammonia. So what is ammonia? NH3. Okay. So this NH3 molecule, it has one nitrogen atom and 3 hydrogen atoms. Okay. So see here, the weight due to nitrogen is 1 into 14. Because why we are multiplying it with 1? Because we have only one nitrogen. So 1 into 14. So it is 14. And how many hydrogens? 3 hydrogens. And each hydrogen, its weight is 1. So 3 into 1. So 3. So now the molecular weight of ammonia is 14 plus 3. That is 17. Okay. Next example. Find the molecular weight of ammonium sulfate. Okay. So what is ammonium sulfate? NH4 taken twice SO4. Okay. One thing, dear students, you all have to know the correct formula. Okay. Until and unless you know the correct formula, you cannot get the correct weights. Again, I am keep on telling you, you have to learn the correct formulas. If you write the correct formula, then only you will get the correct molecular weights. And based on the molecular weights, only number of calculations are there. So please learn the correct formulae. In your 9th class, you have learnt polyatomic ions, carbonate, sulfate, hydroxide, all these. If you practice them, then you will be able to do it. Okay. So let us see here. Ammonium sulfate. So what we are noticing here, NH4 taken twice, SO4. So this 2 has to be multiplied for nitrogen as well as for hydrogen. So you see here, 2 into 14, 28. That is the weight of nitrogen. Now here see hydrogens. Totally how many? 4 into 2 into 1. So 8. And how many sulfurs are there? Only S. That means only one sulfur. So 1 into 32. And how many oxygens are there? 4 oxygens. So 4 into 16. Okay. So if you add up all this, 28 plus 8 plus 32 plus 48, you will get it as 116. So 116, this is 116 is the molecular weight of ammonium sulfate. Okay. And please note it down. Today your homework would be, you have to learn the atomic weights of first 20 elements. Better if you learn 30 elements, but let us start with small things. You have to learn the atomic weights of first 20 numbers. And as well, please refer to your 9th class textbook and learn the polyatomic ions. Sulfate, hydroxide, carbonate, all these you have learned. Okay, that revision has to be done. Okay, and one more thing, I would like to say that Pooja and B. Durga of Hassanpati, these students have done their homework and even they have posted their work to me. I'm really very happy for these two girls. You all might be doing, but please practice on the same day itself. If you practice on the same day itself, it would be very much easy. Okay. Hope you have understood how to calculate the molecular mass. Next important topic is, that is, subtopic is formula mass. Okay. So only the name of change of name over here. Formula mass is nothing but it is the molecular weight only, but for ionic compounds. Okay. It is for the ionic compounds. Already you have learned what are ionic compounds in chemical bonding. Ionic compounds are those which are formed due to the ions. Okay, how are ions formed? Because of losing or gaining of electrons. Okay, once an atom loses the electron, it forms a cation. Okay, and if an atom gains the electron, it forms an anion. Cation is positively charged, anion is negatively charged. Okay, and we know that there exists attractive forces between positive and negative ions. Okay, for example, we'll see common salt. What is that? NaCl. It is made up of Na plus and Cl minus ions. How is Na plus formed? When sodium loses one electron, it forms Na plus. And Cl minus is formed when chlorine atom gains one electron. Okay, so whatever the electrons sodium has lost, that electron is gained by chlorine. Okay, so we are getting the ions, that is sodium cation, chlorine anion. Okay, and there exists the attractive forces between these ions. Okay, and that is how the ionic compound has formed. Okay, so one thing we need to know that ionic compounds, they do not have a simple structure. For example, if you take NaCl, okay, it has face-centered cubic structure. This you have already learned. It has face-centered cubic structure. That means each Na plus is surrounded by 6 Cl minus ions, and each Cl is again further surrounded by Na plus ions. So they do not independently exist as units. So for that reason, instead of calling them as a particular molecule, we call them as the formula unit. Okay, so formula mass is the sum of the atomic masses of all the atoms in a formula unit of an ionic compound. Okay, same way how we have calculated the molecular weight, same thing only, same calculation only, but only thing we have to call it as formula mass. Okay, formula mass is used for ionic compounds that have no definite molecular structure. Okay, that's what just now I have explained, right? They do not have definite molecular structure because each ion is further shared by different ions. Okay, attractions are there. For that reason, we say that ionic compounds do not have definite molecular structure. Okay, so let us see an example. Fe2SO4 taken thrice. So what it is? Iron sulfate. In the common language, we can call it as Fe stands for iron. SO4 stands for sulfur. Okay, we have to say it as iron sulfate. Okay. So let us see the calculation of formula mass of this. So Fe2, that means 2 iron atoms are there. So 2 into 55.845, or you can round it off to 56. So 2 into 56 also you can take. Okay, and you see here, SO4 taken thrice. Okay, that means this 3 has to be multiplied for this sulfur, as well as 3 has to be multiplied for this oxygen. So 3 in. So here what we are seeing is directly they are taking the weight of sulfur as well as 4 oxygens multiplied with 3 that they are taking. Okay, individually you can take 3 sulfurs, weight of the 3 sulfurs plus weight of how many oxygens? 4 into 3, 12 oxygens you can take. If you do either way, you will get the correct answer, that is 3399.879. So this is the formula mass of iron sulfate. Okay, particularly if you have to say it as ferric sulfate. Hope you have understood it. So please note it down. You have to calculate the molecular weight of glucose. So what is the formula of glucose? C6H12O6. This is your homework. This one. Calculate the molecular weight of carbon dioxide. What is the formula of carbon dioxide? CO2. Okay. Next, another molecule, H2SO4. What is this called as? Sulfuric acid. Okay. So today's your homework is calculate the molecular weight of glucose, carbon dioxide, sulfuric acid, and calculate the formula mass of barium chloride. What is the formula? BaCl2. Please make it note it of it. Make a note of it. BaCl2. Okay. Another example is magnesium sulfate. So calculate the formula mass of these compounds. Next topic is mole concept and molar masses. I request all the students to pay 100% attention and please listen to this concept. This is very important and number of questions are asked for all your competitive exams based on this concept. This is very, very important. Yeah, let us see.
Madam,
Sir?
kindly close the session.
Sir?
Kindly close the session.
Okay, sir. So please students, if you practice the molecular weights, then tomorrow we will discuss about the mole concept. Okay? Please do the homework. Today's homework is you have to calculate the molecular masses for glucose, carbon dioxide, sulfuric acid, okay, barium chloride, magnesium sulfate. As well, I told you to learn the polyatomic ions and atomic weights of first 20 elements. Please do this. Okay, let us see the remaining part tomorrow. With this, I wind up. Please do the work.